going to solve another coding problem, which is basically related to the previous problem that we did on merge two sorted lists. So what this problem wants us to do is that we want to merge k sorted lists. This basically means that we do not know the number of linked lists. And in this case, we could be given 5 linked lists, we could be given no linked list, we could be given 10 linked lists. We do not know the numbers, so that is what this problem wants us to do. So given a number of linked lists, we should go ahead and return it as one sorted linked list. And here's the example: 1, 4, 5, 1, 3, 4. In this case, we've been given 3, and then it's going to return it as one sorted linked list. So there is many ways that someone can approach this problem, and we're going to try and look at 2 ways. And the first and basic way that someone would think about would be the brute force approach. And how to do that is that you would go ahead and traverse all the linked lists, and then afterwards you would collect all the values in an array. So after collecting all the values in an array, what you'd want to do is that you would go ahead and sort the array, and then iterate over this array, creating a proper value of nodes. And then using the nodes, you'd go ahead and create a new sorted linked list. So that is all you're going to do, the brute force approach. So you're going to go ahead and create an empty array, and then you're going to go ahead and create a new linked list using a 0 pointer, and then we'll go ahead and iterate through the linked list. So while L, what we want to do is that we want to append, so self.nodes.append l.val. So l.val, so we're going to append all the values in this array here, and then after doing that, we're going to iterate to the next value of l. So after doing that, we would go ahead and sort. So for x in sorted self.nodes. So sorted is an inbuilt Python function, so it is going to sort the array. So it's an easy way of sorting the array. So what I want to do is that point.next would be equals to, we're going to create a new node using the values, and then point is equal to point.next. So after doing all that, we want to return head.next. And that is the brute force way of solving this problem. So let's go ahead and see. And yes, our code actually works fine. So the only problem with this code would be that it should actually occupy a lot of space. So let's go ahead and submit and see. And our code is actually 94% faster than other submissions, which is actually a good thing. So the time complexity here is O(n) log n. And to the next problem. So let's go ahead and solve it using the next solution. So in this case, I'm going to use a min heap. So it's actually a good thing that you should go back and read about min heaps and know how they work, because it's actually a more optimal way of solving this problem. So I'm going to import heap pulp, and then also going to import heap push. So we're going to go ahead and have these variables, pointer, and then the values is going to be the array, the empty array, and then we're going to have none and another none. So afterwards, you're going to go ahead and iterate or traverse through the lists. And then while doing that, we're going to, so while L, what we want to do is that we want to put all the values in this array, that we created here. So what we are going to do is that heap push values, then l.val. Otherwise, L is equals to L heap.next. So you iterate to the next one. And then while doing that, we're going to go and have iterate through the values that we just created. So in this case, we want to go ahead and sort them. So if head is none, what we want to do is that we're going to go ahead and create a new node using the values. So heap pop. So what heap pop does is that it's always going to pop out the smallest value. So we want to sort it using the smallest values, of course. So we're going to do that. And then we would go ahead and change the pointer to the head. Otherwise, I'm going to do this is equal to list node heap pop values, just the same thing. And then pointer is equal to pointer dot next. So after doing all that, we would go ahead and return the head. So that is a more optimal way using heaps. So a min heap. Let's go ahead and see if it works. Yes, we have a problem. Yes. Okay. So our code actually works fine. So let's go ahead and submit it and see what it's gonna do. And yes, so it's actually faster than 99%, which is actually a good thing. So the term complexity here is O(n) log k. And this is a more optimal way of approaching this problem. There are other ways that you can solve this. You can use priority queues, but then again, you can implement priority queues using min heaps. So yeah, I hope that whenever you come across this problem in an interviewing setting, you'd actually know how to approach this. And yeah, so thank you so much. I look forward to seeing you on the next coding problem. So yeah, thank you.